Hello again. Today we are covering section 9.5, solving rational equations. A rational equation is simply an equation that contains one or more rational expressions within it. For example, the red equation here. Rational expression, rational expression, rational expression. Left-hand side is one rational expression, and over on the right-hand side, you will notice, as I uncircle things, that we are taking two rational expressions and we are adding them together. Our method for solving a rational equation is going to sound an awful lot like how we were simplifying rational expressions when we were adding them together. We need to find a common denominator. The cool part is once we have that denominator, we can then ignore it all the way until the very end of the problem, and the only reason we would want to check them is to see if any of our solutions would create division by 0. Our first example, x plus 1 over 3x minus 6 is equal to 5x over 6 plus 1 over x minus 2. It's the red equation that you saw a moment ago. Let's start by factoring the denominators. 3x minus 3 is 3 times the quantity x minus 2. 6 is 2 times 3, and yes, that will be important to us. And there's no factoring to be done in the final denominator, it's x minus 2. So the least common denominator will have to include the 2. It will have to include the 3, but good news, that also takes care of the 3 that we have here. And it also needs to include the x minus 2 binomial that appears on the left-hand side and in one of the denominators on the right. So our least common denominator is 2 times 3 times x minus 2, and yeah, you could call it 6 times the quantity x minus 2 if you want. There's some benefits to not doing so at this time. Realize, if you would please, that the left-hand side, that fraction has everything we need except the 2. So we will multiply the top and the bottom by 2. The rational expression that starts the right-hand side, the 5x over 6, has the 2 and the 3, but it does not have an x minus 2, so we'll need to multiply by x minus 2. And the 1 over x minus 2 is missing the 2. It's also missing the 3. And as promised before, once we have the common denominator, we'll set it aside, so we're not worrying about the 2 times 3 times quantity x minus 2. We'll come back to that later. Right now, we're focused exclusively on the numerators, and we have x plus 1 times 2, which when you distribute the 2 will give you 2x plus 2, is equal to 5x times the quantity x minus 2. We'll distribute again. This time we get 5x squared minus 10x. And then we have 1 times 2 times 3, which is 6. This is shaping up to be a quadratic equation, as indicated by the fact that there is an x squared term that's not going anywhere. When we put all of the terms together by subtracting 2x from each side and subtracting 2 from each side, we get 5x squared minus 12x plus 4. And we need to factor, or we need a quadratic formula. Your choice. I'm going to factor, and I'm going to go straight to the answer here because I know you're an expert at factoring. 5x minus 2 times x minus 2, and if you want to double check that does give you back 5x squared minus 12x plus 4, you are welcome to do so. This is implying that we have a solution of x equals positive 2/5 and a solution of x equals 2. But, hold on a minute. We still have to worry about the LCD. So we come back to the least common denominator. We come back to anything that's going to cause division by 0, and we said that least common denominator was 2 times 3, or 6, minus 2. Yeah, I wrote it as 6 instead of 2 times 3. It's not really a big deal. If we replace x with 2/5, the least common denominator will not be 0. We don't care what it is, as long as it's not 0. So 2/5 is good. The problem is if we replace x plus 2, or excuse me, if we replace x with 2, then we would have 6 times 2 minus 2, or 6 times 0, which is 0. So we kill the x equals 2 term because that is causing division by 0. And the only solution to our problem is 2/5. The only value of x that will make the original equation, which, by the way, if you haven't noticed, is in the top left corner, the only value of x that will make the original equation true is 2/5. Let's see this again with another problem. This time, there's no factoring that has to happen to find the LCD. The left-hand side has a denominator of x plus 2, so it's pretty safe to say that x plus 2 will be part of the least common denominator. We also have an x minus 2, and there's another x minus 2. We don't need to include it another time. As long as it's coming up at least as many times as it appears in any denominator, then we are safe. And this means that we will take the first rational expression and multiply top and bottom by x minus 2. We take the second rational expression, multiply top and bottom by x plus 2. And we go over to the right-hand side, and we need to multiply the bottom by x plus 2. That means multiplying the top by x plus 2. And right now, since we are about to say time to disregard the denominators, we're interested in solving this, which through the magic of technology is now appearing at the bottom of the screen. We'll do a little distribution while we're here. X times x is x squared. X times negative 2 is negative 2x. We need to FOIL. X plus 2 times x plus 2 will give us an x squared plus 4x plus 4. I'll worry about the fact that we're subtracting that polynomial in a moment. And over on the right-hand side, x plus 3 times x plus 2, we know this well. It gives us x squared plus 5x plus 6. So let's go ahead and distribute that negative sign. X squared minus 2x minus an x squared minus 4x minus 4 equals x squared plus 5x plus 6. Conveniently enough, x squared minus x squared are going to drop out, and we are left with the quadratic equation x squared plus 11x plus 10. And this factors as x plus 10 and x plus 1, which gives us possible solutions, and I call them possible because we need to check them against the LCD, of x equals negative 10 and x equals negative 1. So let's see if they work. We'll take the x equals negative 10, go back up to the LCD, replace x with negative 10. We're getting negative 8 times negative 12, whatever that is, it isn't 0. So negative 10 works as a solution, and then we'll do the same thing with x equals negative 1. Plug it back in up top. If x is negative 1, we have 1 times negative 3, which is positive 3. Again, that's not 0. And so x equals negative 1 is a solution. It turned out in this case that they both worked. It may be that only one of the two solutions that you come up with works, the other one causes division by 0. It may even be that you get to the end of the problem and you discover that there are no viable solutions to the equation. Let's see what happens when you give it a try. This is your problem. X plus 2 over 2x plus 1 equals x over 3 plus 3 over 4x plus 2. Remember to get an LCD, and then once you have that, you can disregard the LCD until the end of the problem. So let's go after that LCD. First off, the first denominator does not factor. There's nothing we're going to do about that. And for that matter, 3 doesn't factor. The only thing that we have here to work with is a 2 times 2x plus 1. So our least common denominator needs to include both the 2 and the 3 that are monomial factors, and it also needs to include a 2x plus 1. So let's go through these one at a time. The x plus 2, the only thing missing from the least common denominator were the 2 and the 3, so I'm just going to go ahead and say we're multiplying by 6. X over 3, we need a 2. We also will need the 2x plus 1. And then over here we have 3. The denominator has a 2 in it. It has a 2x plus 1 in it, but it's missing another 3. And it should go without saying that these all are over the least common denominator that we are ignoring for the moment. So I've cleaned up that last line of work a little bit and also made a note of the least common denominator. As we continue our work, we'll distribute so that the left-hand side is 6x plus 12. The right-hand side is 4x squared plus 2x plus 9. And we'll move all of the terms to one side of the equation. For 4x squared minus 4x minus 3. And again, this is factorable. If you choose to use quadratic formula to solve this, you are certainly welcome to. The factored version of the right-hand side is 2x plus 1 times 2x minus 3. And that implies that x could be negative 1/2, or that x could be positive 3/2. So check them and see what happens. If we replace x with negative 1/2 up here, we're going to get division by 0. 2 times negative 1/2 is negative 1, plus 1 is 0. The least common denominator becomes 0, and so x equals negative 1/2 is gone because we cannot divide by 0. If we went back and checked this again with the 3/2, what we'll find is that 3/2 will work. Plug it back in, we'll have 6 times 4, which is 24. That certainly isn't 0, and so 3/2 works and negative 1/2 didn't. So the only solution to this problem is x equals 3/2. Now, what kind of fun would this be if we didn't throw in some word problems? Here we have Ken. Ken has started bicycling because his doctor told him it was great exercise. One thing his doctor suggested was to find his normal bicycle speed, etc., etc. We skip down to where it says that on a particular day, the wind added 3 kilometers to his rate when he was cycling with the wind. So we'll make a note of that. That when he is cycling with the wind, he gets a 3 kilometer per hour advantage. It also states that when he is going against the wind, in other words, on his return trip from wherever he rode his bicycle to, he has lost 3 miles. So when he is against the wind, he is losing 3 kilometers per hour. Ken discovered that in the same amount of time that he could cycle 36 kilometers with the wind, he could only go 24 when he is against. And what is his normal bicycling speed with no wind at all? Well, some things that we should recall. Recall that speed is equal to distance over time. Now, the constant that we have is time, so the equation that we just wrote about speed equals distance over time is equivalent to saying that the time is equal to the distance traveled over the speed. And we have 2 equal amounts of time because he traveled 36 kilometers with the wind at his back, and he traveled 24 kilometers in the same amount of time when the wind was in his face. And so we'll set up a very simple rational equation. If he can go 36 kilometers with the wind at a speed of r plus 3 kilometers per hour, and we know that that's equivalent to him traveling 24 kilometers when his speed is reduced by 3 kilometers per hour. We can find that speed very simply by the old technique of cross-multiplying. We have 36 times r minus 3. And we have 24 times r plus 3. $36r minus 108, 36 minus 3 is 108, is equal to 24r plus 24 times 3 is 72. And so putting all the r's on one side will give us 12r, putting all the not r's on the other side gives us 180. So if 12r equals 180, we can do a quick division here and conclude that r, which is his speed, I chose r here for rate, since I didn't mention that before. I should have mentioned that. We are saying that his rate with no wind factor is 15 kilometers per hour. So with no wind, he is traveling 15 kilometers per hour, which would jive with the idea that when he is riding with the wind, he's going 18 kilometers per hour, and when he is facing the wind, when he has to fight the wind, he's only able to travel 12 kilometers per hour. Let's finish with a problem for you to do. Most tunnels are drilled using tunnel boring machines that begin at both ends of the tunnel. Suppose a new underwater tunnel is being built and one tunnel boring machine alone can finish the tunnel in 4 years. So if he's going all by himself, he'll make it across in 4 years. But we're not interested in that, so we're going to get rid of that arrow. We're interested in the idea that one of these borers is coming from one side, the other tunnel boring machine comes from the other side, and they're going to meet in the middle. So one can do it in 4 years all by itself. The other one can do it in 3 if they're starting at opposite ends, and they work at the same time. When will the tunnel be finished? Please answer in years. Okay, so it would be nice to know that Machine A is able to do the job in 4 years. That means that in its side of the work, it's doing 1/4 of the job per year. On the other side, Machine B is doing 1/3 of the work in a year, and together they need to equal 1 tunnel. Since common denominators would be nice, or certainly getting rid of the fraction, let's see if there is a number that we can multiply everything by and get rid of all of the fractions. And that magic number, that magic common denominator, is 12. So as soon as we multiply every single thing here by 12, x over 4 times 12 becomes 3x. X over 3 times 12 becomes 4x, and 1 times 12 is 12. So we have 7x equals 12, and we will conclude that the job can be done in 12/7 of a year. Now, some of you like your mixed numbers. So that's 1 and 5/7 years. It's roughly speaking about a year and 2/3, a year and 3/4 in that neighborhood. And that's how long it would take if the two machines were working together from opposite ends and meeting in the middle somewhere. That's all for today's lesson. See you next time. Thanks for watching.